Okay, we can go ahead and get started. My name is Beruz Chitsas. Before I get started, I wanted to introduce you to two other sort of virtual members of the team who are not here, but they're a very important part of the team. They're the researchers who've been working on the project that I'm going to be talking about, Frank Zaide and Kit Thamranatnam. There are many reasons why this is really a very interesting topic for research. One is that it's an extremely challenging area for research. Speech recognition is very challenging. We can sort of talk about that. I'll sort of mention why it's challenging. The other reason is that there are a lot of technology trends that have resulted in an explosion of multimedia on the internet. When you think today, just on YouTube, for example, every minute there's about 20 hours of video being uploaded. Every day there are millions of hours of audio video being uploaded on the internet. And it's been driven by several different things. One is storage costs. When you look at storage capabilities, I mean, today you can get a terabyte of storage for about $100. And that's just incredible when you think about that. I mean, you have to put that in context. You know, we've sort of become a little bit immune to technology advancements. On a terabyte, everything a human says in an entire lifetime, you can store on a terabyte. When you think about it that way, then you say, wow, that's incredible. Does that mean my life is worth $100? I don't think so, but it's just remarkable when you think about that. And that's sort of a very big driver of why there's just so much audio video. The other part of it is other things are like network capabilities, whether it's wireless or wired. Bandwidth has increased, so allowing people to upload a lot more multimedia content. Also capturing devices. You look at every cell phone now has a camera, and those cameras are getting better and better. They're starting to get autofocus, good microphones on them. In offices, you have a lot of content that's being archived in the government. So there's enormous amounts of content being generated. The other thing is, from a social perspective, we want to share our information. When you put all these sort of different factors together, you've got massive amounts of storage. On the internet, you've got social computing. People are socializing a lot on the internet, and they want to share their experiences, where they've been, what they've learned, the information they have. So that basically means that it's driven an enormous amount of multimedia on the internet. And that's sort of, those are sort of the reasons why it's really interesting for Microsoft Research to be in this particular space, and why I think it's very important for us to work on it. Before, I also wanted to sort of quickly introduce Microsoft Research. I know Bill Buxton had a keynote, and Vikram, my colleague, talked about machine translation. We started in 1991. One of the reasons that Bill created Microsoft Research was for us to think 3, 5, 10 years out so that our products would have a future. Because he saw the rapid change that's happening in the IT industry. So we have about a little over 900 researchers now. We have labs across the world, the biggest lab being in Redmond, Washington. We have one in Beijing, China, in India, in the UK, and several other places as well. And we work in nearly every area of computing you can think of. Anything from computer languages, operating systems, graphics, information retrieval, knowledge management, databases, and of course speech and next generation user interfaces. Nearly every area of computing that you can think of, we've got some sort of a project in that. It's a very open research culture, so very flat structure. The researchers are pretty much, free to do whatever they want, whatever areas that interest them. And it's really nice being part of Microsoft, because we have, in every area, we basically have some sort of a product in that particular area. If you're into graphics, well, you can get your technology, your ideas into Windows or Xbox. We even have sort of hardware as well. So there's a lot of places that you can actually see your research come to fruition and come to market. So it's really nice being part of Microsoft Research. We've had a lot of impact on the product groups. Nearly every product you can think of has had something that has gone from Microsoft Research into it. The most recent one, Project Natal, which is essentially turning your body into a controller for the game. That's something that originated from Microsoft Research. But from early on, the grammar checker on Word, in Microsoft Office, we actually have speech-to-text. All of that stuff originated from Microsoft Research, but there are a lot of examples like that. I wanted to put sort of speech in the context of other multimedia work that we're doing. So there's a lot of other work that we're doing in this particular space. It's very rich from a research perspective. When you look at, just walk through some of these things, video summarization. I mean, today you summarize videos basically based on scene detection. It's mostly sort of temporal. One of the things we want to do is do video summarization based on the content of the actual video. Let's say you're sort of, you're going whale watching or something, and you want to essentially pull together the parts of the video where you're taking the video of your family, and then on the sea where the whale sort of jumps out the water or whatever, and then you sort of get back to your family and so on. So what you want to do is you want to be able to summarize it based on the content, based on the scene, rather than temporally. So there's a lot of interesting work in that space. Semantic extraction. Wouldn't it be great if you could the machine could automatically commentate a game, let's say a basketball game, and you would essentially teach it what a three-pointer is, what a two-pointer is, what left court is, what a foul is, etc. And you just hand it, and the actual system would go and actually do the commentating for you. So that's the idea, that having the system sort of understand what's happening inside the video. Face identification, that's kind of another sort of interesting research area where people have been working on that for a long time, and it just gets, it gets improved and it gets better and better. But there are a lot of interesting scenarios there. You want to be able to find photos that you've taken with your family in front of the Eiffel Tower or something, in Las Vegas. So those are, there are a lot of sort of interesting technologies in that space. Object recognition. Inside a video, you want to be able to determine what's a truck, what's a car, what's a bus, what's a Coke can, what's a computer, those kind of things. So we're doing a lot of work in that space. Visual search, instead of providing textual information, you could provide it, let's say, a video or an image, and finding other images which are similar to that. And maybe you want to provide some hints on top of that as well. Maybe you want to sketch something and say, find me things which are kind of similar to this. And you're sketching and providing it with some image, and having it come back with video or images similar to that. 3D modeling. When you take a video from a scene, it would be great if it actually turned into a 3D model so you could actually interact with it. Let's say a cruise ship. You take a video of the cruise ship, and what you want to be able to do is you want to be able to interactively walk through that cruise ship and get that immersive experience. Those are some of the things that you could potentially do there. But we're here to talk about speech. So let's go ahead and start talking about that. Before I get to sort of where we are today, one of the things that we showed at an event, we have this event called TechFest every year, where we bring in researchers from around our labs, and we have turned our conference center into sort of a trade show, and we have the researchers show their stuff to the product groups, and it's a great way of building relationship between the product groups and the researchers. One of the things that we showed at this past TechFest was the translating phone. This brings together speech recognition and machine translation, which Vikram, my colleague, talked about on Monday. They had some really interesting announcements, new APIs that they've released, as well as a community-based way of doing translation, so it improves the accuracy, and also speech to text. So this brings together a bunch of different technologies. You can think of this more as a vision that's sort of a product that we're going to be releasing next year. But when you look at this, try to think that when the accuracy of these things go up, what really interesting scenarios you can enable.
From the last ones, in that here we're going at a sort of different aspect of the natural user interfaces, really looking at being able to do speech recognition and machine translation and integrating those together. And Frank and Kit are going to, from our Microsoft Research Asia, will give you an idea of sort of what they're doing here, what they're trying to accomplish. Again, this is all by way of trying to understand what we are able to do and to think about the kinds of applications we'll be able to build in the future that allow people to communicate better together. So,
yeah. Okay. So thanks for the intro. Yeah, so as Rich said, what we're showing here is what we think is going to be the next big direction for voice communication, unified communications. You may know next versions of Exchange are going to have voicemail transcription. We do something crazier. We do full transcription of an entire telephone call. And then we're crazy enough to even try to do translation live on that. So if you step over here into my office in Australia, and in sunny Australia, I'm now going to make a call using Communicator to my colleague Frank in Germany, rainy Germany. So I'm going to start a voice call. Hello? Hello? Okay, so what you're seeing here is everything I'm saying is being transcribed automatically by speech recognition. And then it's pasted here into Communicator. And that's going to get archived automatically in my Exchange inbox, so I can come back and search and forward and browse my telephone calls. Okay, that's already pretty cool, but we do something even more ambitious. Frank, you've been very quiet.
Ja, dafür gibt es einen Grund.
Yes, there is a reason.
Weil ich kein Englisch spreche.
Of course, no English speaking.
But we can understand you very well, so can you explain why?
Ja, in diesem System kombinieren wir Spracherkennung mit automatischer Übersetzung.
Yes, in this system combines speech recognition with automatic translation.
Und dann an automatische Übersetzung weitergegeben.
Everything I say is recognized by a speech recognizer, and then passed on to automated translation.
And then this is synthesized using text-to-speech. And we do have German synthesis as well. Okay, I'm not going to show you that because I assume not everyone here speaks German, so we'll mute that for now. Now, Frank, what about the accuracy? What do you think?
Naja, es ist offensichtlich nicht perfekt.
Well, it's obviously not perfect.
Aber man kann durchaus bereits eine Unterhaltung mit dem System führen.
But we can certainly already lead a conversation with the system.
In fact, we developed some of this software using this system where we had a fully bilingual conversation. It is doable, but you do need to give a little bit of attention to what you say and how you say it.
Ja, und besonders wenn man keine Alternative hat, kann man mit dem System durchaus gemeinsam Probleme lösen. Das System erfordert zugegebenermaßen ein bisschen Übung.
Particularly if you have no alternative, it will solve quite common problems with the system. The system requires admittedly a little practice.
And we do give some help to make sure that the translation is working well. You would have noticed here the live transcript here, which tells you if the recognition is working well. Also here, you will see what we call the retranslation. Here we translate first from English into German and then back into English. So this gives you an idea whether what you're saying is going to get translated well or not. Okay, many technologies come together to make this work because this is an incredibly difficult problem. And, you know, we're doing live speech recognition here. This is highly impressive or highly entertaining at least.
At least it's highly entertaining. But it worked pretty well. Actually, what Frank did, he actually used the way that he got sort of German to work is just through about 40 minutes of speaking with his mom, and he used that in order to generate this the language model for this. So So that's basically, that's kind of more of a vision. Today, there's, in terms of sort of speech applications, I would probably put them in two different categories. One is speech as an interface, whether it's from a search for mobile perspective. So there's a lot of technologies out there, services out there that allow you to speak something and be able to get information. In terms of automation, automating websites with speech, again, lots of different websites out there that are especially for sort of help purposes that you can actually enable with speech, and also text input. Now, the interesting thing here is that in these cases, you're having a single person speak to the system. The other part is the other category of applications are using speech more as a first-class content. So you want to be able to, for example, search it. And that basically means you're now talking about speech that comes from multiple different people, and it's got conversational in nature, so it's not very sort of dictation-oriented, or it's not based on a certain very, very limited vocabulary. And it makes this is what makes these things sort of harder. So as you go from left to right for each of these things, it just becomes harder and harder from a technology perspective. And from top to bottom, it gets harder as well. And also transcription then. So taking your meeting notes or taking voicemail and transcribing those things. The other is translation, which is kind of, now you're taking a few different technologies and putting them together, and frankly, none of them are perfect. So in the end, what you end up with, it really depends on how well you've trained it, what domain, those kind of things. Today, that's where it is, but that's where we'd really like to go. Today, what do we do? So today, when we want to search audio, video, you're getting the metadata around it, the textual metadata, but of course, let's say it's a 2-hour lecture and you want to find some information in the middle. Let's say that somebody writing something on a whiteboard and you want to get to the point where they're actually writing something, doing an architecture diagram, and you want to be able to search that. And those are the kinds of things that you can't really do very well today. You can sort of search based on the textual information around the media. Sometimes that textual information may not be as relevant to the actual content as the actual speech content itself. So what we would really like to do is to be able to enable you to search conversational speech, massive amounts of information. So we're talking tens of thousands of hours of audio, essentially, maybe millions of hours of audio, so in a very, very scalable way, and highly accurate. So that's speech recognition. People have been working on speech recognition for a very long time. So the thing isn't that this is not brand new. Doing speech recognition isn't new. It's about what techniques do you use to make it highly more accurate. And those are some of the things that I'm going to be talking about. So here's a site that we have, which is actually, it's on the internet, so you can go and try this out. Right now, we've indexed Channel 9 and the PDC 2009, but we're working with some early adopters as well, so we've indexed some content from some other companies and some government organizations as well. So let's go ahead and search for, let's search for Bill Buxton. So what I'm doing now is essentially searching the textual metadata as well as the content to find out who actually spoke about Bill Buxton, who mentioned Bill Buxton inside their talk. Okay. Oh, actually, Scott Guthrie talked about Bill Buxton. What you'll notice here is the bold, sort of the black stuff, that's the textual metadata. This gray info is what was extracted from speech recognition. So I can click on it and I can jump to the point where Bill actually mentioned, Scott mentioned Bill Buxton.
Build interactive design.
Can we get the volume up?
Bill Buxton uses this analogy. If you think about industrial design, that came about not in the 1800s, not in the 1900s.
The other thing
but
you'll notice is that down here we've got a timeline that actually shows where in that speech, that timeline of the content, Bill was mentioned. And in this particular case here, for example, it was mentioned a few times. Well, back here just once. So let's go ahead and find out who actually mentioned Scott Guthrie. So a bunch of people. And again, what I can do here is click on one of these links and jump to the point where the person actually spoke about Scott Guthrie.
All right, people, we have 5 hours and counting till Scott Guthrie goes on stage to deliver his keynote for MIX. 5 hours, everything is under control on this end.
So there we go. There was a mention of Scott Guthrie. Now, I'm going to open it up, and let's just do this. This is Las Vegas, so it's one of these things where you can actually shout out, what do you want me to search for? So you see, there's no man behind the curtain here. This is for real. So is there anything sort of a Microsoft-related topic or that you want me to search for? Anyone? Silverlight. Okay. What was another one? Sketchflow. Okay, so let me do Silverlight first. Okay, bunch of Silverlights here. And we can just go ahead. I can just, do you care which one of these I look at? Doesn't matter. Okay, let's just do the first one then.
Start with Silverlight. And we're going to talk about kind of just the features that sort of map to SharePoint. So we think about Silverlight being a cross-browser and cross-platform plugin, which is exactly what SharePoint strives to be. SharePoint.
One thing you'll notice is that it's clearly not perfect, right? There are some mistakes in the recognition, but it's good enough for you to be able to filter the search and be able to find the areas that are of interest to you. Sketchflow was another one, right? Try that. Nothing on Sketchflow. Oh. I don't think we'll be able to get it. Oh, there we go. Sketchflow. There is. Thank you. So we can just go ahead and click on one of these now.
Here to my welcome screen. Now, one thing that is very important about Sketchflow is that Sketchflow prototypes, as I said earlier, are real applications from the very first moment on. So you can run these applications and play with them. So let's just do that.
So again, you'll notice that the timeline down here sort of points at sort of where in the speech, the talk, the term was actually mentioned, and you can actually click on this. So let's say you want it sort of more towards the end, where there's mention of Sketchflow, you can click on it and jump to that point.
In summary, we've seen a lot of expression blend Sketchflow to show you how you can create compelling prototypes very easily and in a very powerful manner. And I've also shown you a little bit how you can extend expression blend.
Right now we've got PDC. So in this particular case, it seems like, I don't have a query up here. But you can sort of, let's say, you can sort of search different contents, channel 9, or the PDC, or in all, you basically search all the content, essentially. So, I wanted to, so every time sort of I show a demo and stuff, some people say, okay, so how does this thing sort of, let's scratch the surface and find out how this stuff sort of works a little bit. So I'll say a little bit about sort of how this stuff kind of works. But I'm sure you don't want to get into hidden markup models and things like that. So first thing that we do, you do spectral analysis. And what you do here, you're essentially taking the audio stream and taking sort of the high energy portions of the audio stream and using that in order to do the speech recognition, the second phase of it. The next part is acoustic models, and this is essentially taking every utterance that you make, the smallest element of those utterances are called phonemes. And there are 44 phonemes in the English language. So whether you say potato or potato or roof or roof or data or data, all these utterances, all these words are going to turn into, there are 44 phonemes that are put together in order to create the English language. And that's basically what that acoustic model is all about, is creating these language models about the phonemes. Then you have the dictionary. Actually, what I'll do is I'll sort of move to the next set here. Okay, so that was essentially, in order to get the acoustic models, we train it. So this stuff happens sort of in the lab behind the scene. So this is essentially what the system, we go ahead and we train, take thousands of hours of audio with accurate transcript, and we're talking extremely accurate transcript. Every cough, every every silence, everything gets absolutely transcribed. And we sort of line it up, and we use that in order to learn and create this acoustic model. Next thing is the dictionary. This dictionary is typically sort of hand-done because the different way that people pronounce things, whether it's SQL or SQL, or in this particular case, you've got microscope and, microsecond and macrosecond, or microsecond and macrosecond, Microsoft or Microsoft. The different ways that people actually say things, that's essentially what's being put inside this dictionary. And the third thing is the grammar. And in terms of the grammar, this is essentially what's used in natural language processing, which is essentially mostly trigrams, which are three words that are put together. These are sort of the probability of these things coming together. For example, this is A, as the higher the negative number or the closer to zero it is, it means it's higher probability. So this is A is higher probability than, let's say, this is accomplished. So that's basically what this means. So you essentially create this language model. Now you know that when you get a this, the chances of is next or is A is higher than is about. And this is essentially what you use in order to do that sort of matching. Now, there are a lot of challenges there, as you can sort of tell, different accents. As I mentioned, whether it's roof or rough or data or that kind of thing, SQL or SQL. So there's many different accents that we have to take into account. Background noise. If bus goes by behind you, then where does that sort of energy come? So it becomes very, very high energy during the time when the bus goes by. So you have to now filter that background noise. And there are a lot of interesting technologies that can be used in order to help with that. Microphone arrays can be used in order to filter background noise. You can use headsets, things like that. And in the future, I think mobile phones will probably have multiple microphones that you can use, a microphone pointing out and a microphone pointing to essentially the mouth, so that you can filter out background noise, and that will help with that. Reverberation, a lot of echo around, those echoes, when you think about the machine, it really, as humans, it's amazing how our brains work. We can sort of filter a lot of these things out. But that sort of causes a lot of challenges there. The vocabulary, if you're talking about new things, you get into the healthcare space, a totally different language, basically. So you need to be able to train for that new vocabulary. And different languages. People want to be able to use this in German and French and Spanish and Chinese. So you need to now go and create acoustic models and language models and grammars for all of these different languages. So there's a lot of sort of interesting challenges in that space. And that's why it's taken such a long time. When you really look at technology perspective, 10 years ago, how much video did you have on the internet? There's far, far less than what you have today. So from a technology perspective, it's improved tremendously. While you look at what's taken in order to, how you can actually get at that content, that really hasn't changed. It's mostly today, it's text. Before it used to be text as well. So that's why it's taken such a long time to be able to actually crack open the content. Now, this is sort of where we talk a little about sort of some of the techniques that we use to make the accuracy higher. One of the things about speech recognition is that if you actually apply speech recognition and you take that recognition, the highest confidence that the system thinks, and you use that in order to generate the transcript, a lot of times it's not going to be the transcript that you'll probably get a headache reading that transcript. So one of the things that we do is during the recognition phase, we actually keep word alternatives. So if I say something like Crimean War, system might think I said crime in a war, but I actually said Crimean War. So as humans, again, we understand the context within which we're talking, so we can easily sort of understand what's being said. Systems don't have that context. So that's basically where we keep multiple different alternatives, and then during the search phase, we now have the alternatives so we can hit and find and have better recall rates. And this is why search is probably at this time works really, really well with speech recognition while generating the actual transcript in a conversational way. Now, there are systems that are very dedicated to, say, let's say, the healthcare space. And they do a really good job on the healthcare space when a single person is speaking. That they do a fantastic job there. But we're talking about conversational speech in different environments, different people speaking from about different topics. That's essentially what we're trying to solve, is the very, very general case. So in this particular case, what we have here is from left to right is the timing, and from top to bottom are essentially the alternatives that this system came out with. So let me play this, and you'll see what it's actually being said.
Into this bank account.
So it said, into this bank account, right? So, but you'll see things like spank. What else do we see here? There's interest. So these are the things that the system actually, these are some of the alternatives that the system thought. And by us sort of keeping this information, when you do the search, we can actually better job of actually giving you what you're looking for. So this is called lattice-based indexing. So essentially, during the recognition phase, we don't keep just the highest confidence words, but we actually keep the word alternatives. So that's called essentially the lattice. And by doing that lattice-based indexing, what you're achieving is greater recall rate because you now have the alternatives. And the person who's doing the search knows what context they're searching. They know the archive they're searching. So you get a much better recall rate. We also have confidence levels for each of the words. So you can sort of tune the system and say, I only want things which the system was 90% accurate or 90% confident. So you can actually tune the system for that. And also, there's timing information. So each word has timing info, and that's essentially how we can click on it and sort of jump to that particular point. Another challenge was around vocabulary adaptation. One thing I should mention, when you look at speech recognition technologies, they're really in two different categories. One is phonetic-based, which is essentially you don't turn the actual audio stream into words. You're essentially just searching patterns within that audio stream. And the second one is vocabulary-based, where you actually have vocabulary. Vocabulary-based systems are more accurate because you have that language model. So you have a little more context about the words. They're also a lot more scalable than phonetic-based systems. So in the case of a vocabulary-based system, which is more accurate, what you need is, what you have is a fixed vocabulary. So how do we sort of handle that when I'm given content which is from multiple different domains and we want the system to automatically adapt itself? So one of the things that we do is, given the content, we get as much metadata as possible, which is, let's say, the speaker description of the audio, and we do a Bing search to retrieve more documents associated with that metadata. We extract keywords from that and use those keywords in order to actually train our model itself. So all of this now happens automatically. So if I say something like hypertension, it'll get high blood pressure, because when it does searches on the internet, it'll actually find documents which are related to high blood pressure. And we take all of that information, and because the documents on the internet are used within a context, then we can do a much better job of actually, so it's not just taking the vocabulary, but actually the words are being used within a context. It does a better job of doing the recognition. So that's another thing, another technique that we use in order to improve the accuracy and in order to introduce vocabulary adaptation in a completely automatic way that the customer or consumer just doesn't know about. This stuff all happens sort of on the back end. When we were sort of thinking about putting this together, now we're in research, but this technology is kind of straddling right now research and product groups. We keep very much in touch. We talk a lot with the product groups. We have a group of program managers whose job it is to liaise with the product groups. And this technology is, we think, is extremely important. It's going to change the way that people are going to get information, retrieve information that's inside that's kind of really locked inside the audio, their audio or multimedia. Let me sort of tell you sort of how I sort of started to think that this was really, really important. About a year and a half ago, the State of Washington Digital Archives came to us and said, our tapes are starting to go bad. They've got tapes from the 70s and 80s, and they were digitizing them, but they had no way to find out what was inside them because they had no textual metadata associated with it. It's kind of like backing up and not being able to restore, essentially. So they gave us some of that content. We took that content, we indexed it for them, and they searched it, and then they were like, wow, this is incredible. It really opened us up to find out why we made, for example, a certain decision on a certain bill that was passed. So they could now go ahead and search that content. But even in the case where you do have some textual metadata, it allows you to actually be able to search in a more granular way. So one of the things about this accurate speech recognition is that it's very compute intensive. So what we want to do is we wanted to have a way that it would be farmed out. It's a great example of cloud plus application service where we can farm out the indexing portion into Azure and have it sort of scale, and you can now index thousands of hours of audio without having to put together an infrastructure inside the corporation. Second thing was we wanted to have the content could potentially be anywhere. The content didn't have to be in Azure, although Azure is a great place for you to store the content, but the content could be essentially inside the corporation, and that company may not want to have the content out into the cloud, let's say. So they can actually submit it through PowerShell and some client tools to the cloud and get back the index. This means that the customer can own the search experience. So the search page and the content, all of that stuff, and they can actually integrate it into their search infrastructure. All of that stuff can actually happen behind the firewall. The other thing is that they wanted to have the indexing infrastructure that they were using before. So if they were using SQL or SharePoint or FAST, they could actually use this in order to get the index, and then they would actually use SQL or SharePoint in order to actually integrate it into their textual search engine, so it's textual search infrastructure. So they don't have to introduce a brand new database or brand new system from that perspective. The other thing was that you wanted to be able to very quickly jump to that point. A lot of players today, when you click on something, it has to buffer, and then it starts playing. Well, in this particular case, you could have essentially a 2-hour talk, and the term you're looking for might be an hour inside that audio. If you click on it, you're not going to want to wait for it to buffer, for it to get there. Silverlight, one of the cool things we found about Silverlight is that it allows you to actually seek very efficiently and very accurately inside the audio file without having to buffer. And that was really, really important for us. As soon as I click, I want it to play. I don't want it waiting to buffer. So that was really important for us. So this is kind of the architecture of what we're working on. The entire thing could potentially run behind the firewall. So essentially, the content is given to these client tools as an RSS field, kind of like an RSS text XML file. That gets submitted through the client tool into Azure. Now, what happens is Azure is all of that stuff about vocabulary training and all of that stuff, acoustic model training, all of that actually happens inside Azure. So you don't have to know about that. So you provide essentially metadata, which is, any metadata that you have. The more you have, the better it's going to be, because we use that in order to get more information from the web, in order to improve the accuracy for that particular piece of content. So all of that stuff happens in the background. What you get back is what we call the AIB, the audio index blob. And that audio index blob is essentially that lattice index that I mentioned. Essentially, the word alternatives and where they occurred in the audio stream and what the confidence is. Those are the kinds of things that comes as part of that. But it's a binary file that gets imported into SQL. This part of it now is what happens now behind the firewall, gets imported into SQL, and we have, you can provide tools to that, but that's really simple. And then we have a iFilter DLL, which is the indexing that goes and actually indexes the AIB. So everything else from that point on is just like having essentially a full text index. It's no different to textual documentation. So at that point, it's kind of like whatever the system administrators basically, they're very familiar with full text index on SQL, and nothing sort of changes from that perspective. So what I wanted to do was to show you, let's go ahead and sort of submit something. Some of the tools that we have here. Okay. First, we've got a set of it's sort of a C# XC that we have that I can use in order to submit content, and it's called Mavis Client Tool. So it's pretty simple. You basically sign in, and I've already signed in, so I don't have to do that. And what I can do is, let's have a look at the RSS that I've created. So this is basically the RSS. It's got one item in it right now. You could potentially have multiple items here. Header, the title of the talk, of the content, GUID, which is how it gets identified by the system. Description, again, you could provide as much description as you want. You can provide a link to other documents which are related to this. Again, the more information that you have, the better the system is going to do in terms of the actual recognition phase. And the enclosure in this case, it's actually I put some content on SkyDrive. So it's a link to a SkyDrive video file, basically. So I can move down here. You'll see it's a WMV file in SkyDrive. So let's go ahead and submit this. So this is now creating the web object and uploading the content to Azure, where it will go and get indexed. So it's done the submission. And what I can do is check the status. Oops. Stat. Sorry. So it's going ahead and getting indexed. Now, as I mentioned, its indexing is CPU intensive. Every hour of audio in this case, in fact, one of the things I should mention is that because this deals with audio, if you have video, you could potentially transcode it into just the audio stream and send up the audio. There's no need to send the entire video because it's dealing with audio. So you can save bandwidth from that perspective. So it's going to go ahead and so every hour of audio takes about 5 hours of CPU in order to index, and that could potentially increase. And the more, as I mentioned, the more we spend on the back end training it for this particular content. Right now, it's going up there doing Bing search, finding information about kit and all the description that I had, extracting some metadata, creating a language model. All of this stuff is now happening on the back end on Azure. And then once it's done, I can use the wait command in order to actually bring it back down. And the AIB comes down. Then I import it into SQL, and I'm basically done. So that's it. I mean, that's all you have to do. The other way is through a PowerShell. So this is all sort of pretty straightforward. So I'm logging on, setting up some variables, logging on. This token comes from the Azure logon. Connect to the service. And then what I can do is just submit the content. The content's the same as the previous one. So demo RSS is very similar to what I showed you. And what I can do is get status. So that's basically the running, system's running. So that's essentially what you have to do. That's all you do in order to submit your video files to be indexed, get back the AIB, import it into SQL, and you can now search it, just like I showed you with the demo that I had. Okay, let me see if I... That's basically all I had. So if you're interested in it, I would love to sort of hear about your interest, the fact that you're interested, you think it's important, we're doing the right thing. So So you can send us email to give us your feedback on the work that we're doing in sort of multimedia search and indexing and things like that. And if you want more information about Microsoft Research, there are a bunch of some areas some places that you can go in order to get more information about Microsoft Research. So thank you for your time, and I'll be open to questions. So, thank you. Yes. Yeah, so as part of, I'm in research division. So one of the things that we are going to do is we're going to start to get some early adopters. So please do send me, if you're interested, send me email about, send us email, and we'll just have a look at that. Because we're not a product group, it's not like we can sort of open up right now and really get a lot of content or engage with a lot of customers. But we're certainly open to find out how you're using it, and based on that scenario, we can determine whether it makes sense for us to sort of engage with you at this time or not. But we're open to that. Yes. Yes.
What audio formats do you work with now?
So we can basically anything that's Silverlight support. So WMA, WMV, but we can MPEG-4, and you sort of transcode it into that. It's not a matter of what audio formats. We can do WAV files, we can do FLVs, Flash, but the more important thing is whether you can the actual player can do the seeking that Silverlight can. That's really the key thing. So I've been asked about sort of, do you support this particular format, that particular? It's not about the format. The format we can actually change and transcode. But then once that content, you actually get the AIB back, you need a player to be able to seek without buffering, and as efficiently as Silverlight sort of does. So if you have that, that's absolutely fine. So any content, we could take any content, we'll transcode it to anything we want, and then we'll do the AIB and send you back the AIB, and then you can have whatever you want on the other side.
Now, from an SEO standpoint, the AIB block that you get back, does it have the English words in it that you could expose to the web page so it could be searched by a search engine?
Yeah, yes. So that's one of the things that we are working on. Is as part of the AIB, what comes back is to give you back some metadata associated with that content. Okay. So you can expose that to search engines. Absolutely.
Great, thank you.
You're welcome. Any other questions? I'm sorry, can you repeat that?
Have you looked into whether that metadata works well with the SharePoint file search? Yes, absolutely. So that SharePoint is also we also have I filter DLL for SharePoint, so it's integrated into SharePoint as well. Right now, we sort of focus more so on SQL side, but there is going to be a SharePoint one as well, and we actually have that. Yes.
Yes. Two questions. The first question is, I just heard that gentleman talk about the format of the audio file.
Yes.
And I see that the process is very CPU intensive.
Right.
Which format will be better if I provide to the cloud, and then it can generate faster?
The speed at which it generates, where the time is spent is in doing the vocabulary training and doing the acoustic model training. Those are the things that actually takes the time.
Oh, for the encoding, it doesn't really matter.
For the coding, it doesn't matter. That doesn't really spend. There's no time really spent. It doesn't really matter whether it's Flash or whether that really doesn't matter that much. Most of the time is spent in doing vocabulary training. Remember, what's happening is that we're going on the internet, doing a search, getting a bunch of documents, doing some natural language processing on that to extract some keywords, taking those keywords, adding it, doing phonemes, extracting phonemes for those keywords, looking at how these words actually are used within those documents, and then using that to train the language model. All of this stuff is actually happening in the cloud. So that's where the time is being spent.
I see. The second question is, just example, the audio files 5 minutes. How long it would take to return me the result?
It would take, if it's 5 minutes, it would probably take, and we're going to do more parallelism. But if it's 5 minutes, it would probably take about 20 minutes to get back to 5. But we're using the parallelism infrastructure in Azure in order for us to do even more parallelism. Right now, we're doing it per virtual machine. We have 8 core virtual machines, but we'll be able to do it faster in the future. So we can spread it across many cores. Right now we have, I believe we have about 200 cores with 8 core VMs that are being used right now for this.
Thanks.
You're welcome. Yes.
Talk a little bit about the scalability issues that you guys were facing from vocabulary versus, search.
Yes. So the question was, can I say something about vocabulary-based systems versus phonetic-based? So phonetic-based systems will probably not scale more than hundreds of hours. And the reason for that is doing that pattern matching within the entire audio, essentially. So that's basically what it comes down to. But the other part of it is really the accuracy. That's another area that vocabulary systems are an improvement. We actually have a phonetic-based system it's actually being integrated into OneNote. So you can use that. OneNote 2007, I believe, supported that, and it comes from exactly the same team. The reason we moved to, we were working on both systems, but the reason we're applying vocabulary-based systems for these very large archives is because of this sort of scalability, not only just scalability, but also the accuracy.
Just one of the benefits was typos are easier, like make a typo in Sketchflow.
Yes.
That is easier to find by focus.
Right. So the question was, if you do typos, then it's easier to find in phoneme-based systems. Well, in terms of typos, there's a lot of sort of interesting things that we can apply search. There's a lot of sort of infrastructure that's built around typos, misspellings, things like that in just normal search. Like, so we could potentially, we are going to be using Bing search technology to do whether it's synonyms or whether it's typos. So we can learn by millions of people doing searches and using that determine, aneurysm. Who can really spell aneurysm, right? So we can use the Bing in order to get those alternatives and stuff. Yeah. So there's other ways of getting it. So there's, the other part of it is, for example, ranking. That's again another one of these things that maybe in terms of speech is going to be different to how you rank textual documents. So those are some of the things. We want to provide flexibility so that companies can actually use it in order to provide their own rankings. So they can actually go ahead and change the ranking of the video files that are returned to them. Yes? The question is, does it work as well with music as it does with speech? No, it doesn't. So right now, this is very much focused on speech because the acoustic models are very much conversational speech-based. So now, music is another, we're working on everything, right? So music is, there are companies who actually do music as well. So they essentially create a hash of the first few seconds of the music and then use that hash in order to identify what that music is. I'm not sure if that's what you were looking for or what the user actually is singing inside the actual music. But in order to identify a music, there are technologies that can be applied in order to do that, and we've got that as well. It's basically hash-based. Yeah. Any more questions? Great, thank you very much.